Okay, now it's on. All right, so welcome everybody. We have an exam a week from today. I sent out the review, and the first time I sent it out, did y'all get one email or two? Just one? Got one? Okay, first email I typed up, I explained that this review is just to get you going, and that I will be more specific about that review in class. And then I went to go send it, and it didn't send, so I had to send a real fast one the next time. So it just said, here's the review, right? So please be here next class so I can be more specific about what's on it. We have a ton of material to cover today. I want to get through a lot of stuff. We're going to go through 6.5 and start 6.6. If you're having any difficulty in terms of understanding logarithms or anything like that, we're going to have plenty of examples today, a ton of examples, all right? So hopefully you'll start to get a better feel for logarithms. So let's just do a quick recap of what a logarithm is. So when we write something like log, and then we say base a of x equals y, that's just new notation. That really means that a raised to the y equals x. And I showed you this thing that I called the loop, right? This loop. The way to go from here to here, you do this loop, right? A raised to this must equal this. And so this is called the logarithmic form of something, and this is called the exponential form, right? So if you see a logarithm in there, it's the logarithmic form. If you don't see the log, it's called the exponential form. And so what we're going to do today to start 6.5 is we're going to talk about the properties of logarithms. All right? And then after we figure out the properties of logarithms, we're going to try and get into 6.6 where we're going to use those properties to solve trigonometric equations, wrong class. We're going to be solving logarithmic and exponential equations. Any questions before I start? Everyone's okay with this notation? Okay, so let's talk about the first property of logarithms. So 6.5, properties of, I'm just going to say properties of logs. All right, first property. First property, this is all in the notes, it's all going to be on the board, but let me just put it here. First property says, all right, if you take the log of any base of 1, you get 0. We actually did talk about that last class. We did mention this. And my question is, why? Why is this true? Well, do the loop. Do the loop. What does the loop say? A raised to the 0 should be 1, right? And that's true, isn't it? Any number raised to the 0 is 1. Any number raised to the 0 is 1. Have you ever wondered why that's true? Why any number raised to the 0 is 1? I can give you like a rough proof of it. You don't want to see or no? Yeah, I'll try it. Let me try this. If I write down 3 cubed, this is not a proof by any means, but it's at least to help you feel better about it. 3 to the third power is 27, right? Okay. What's 3 squared? Well, that's 9, right? What's 3 to the first power? 3. Okay, what's happening each time I go down here? I'm dividing it by 3, right? What's 27 divided by 3? 9. What's 9 divided by 3? 3. So logically, the next thing should be 3 to the 0, should be that divided by 3, which is 1, okay? Now, what happens if I keep going? 3 to the negative 1, didn't we say we could write that as 1 over 3? Well, isn't that what you get when you divide that by 3? You get 1/3. And then what would 3 to the negative 2 be? Well, that's 1 over 3 squared is 9, but that's the same thing that you get if you divide that by 3. You get 1/9. I don't know, that's not a proof, but at least that makes you feel a little better that any number to the 0 is 1. That would work for anything except 0. 0 to the 0, different story, all right? And that's, you study that in calculus. Okay, all right, so we have this first property, right? This works for any log. So remember the 2 special logs we had? The 2 very special logs? Log base 10 and log base E, which was the natural log that had that special. They both have special notations. So what I'd like to do is I'd like to write this property, this exact property, using those two special ones. So if I do the first special one, it would be log base 10. Do we write the 10? No, but we can put the 1 there, right? And then put this equals what? If you plug 1 into any log, you get 0, right? I'm just showing you, this is the general property, but this is the property being applied to one of those two special logs. And then what would it be in that other special log? How do we do it? ln, right? Natural log. And then we put 1, and you get 0. Okay, this one right here, you're going to see a lot as you move on in math. And that's just kind of like if I said, what's 1 plus 1? Everyone's like 2, right? What's natural log of 1? 0. You should just know that that's true. Natural log of 1 is 0. All right, you ready for the next property? Good. All right, next property is, let me follow the order of the book here. Okay. The next property says that if you take A and you raise it to the log base A, now they use M, but I'm going to use X. A raised to the log base A of X. The way you want to look at this is you have to remember that the logarithm is the inverse of the exponential function, right? First I introduced exponential functions in this class, and then I said last time, I said, hey, do these exponential functions have inverses that undo them? I said, yes, but it's kind of weird. We can't solve for y, but we have this special notation. So what's happening here is you're taking the logarithmic function, right? Log base A of x, and you're plugging it into the exponential function. See, it's up in the exponent? So you're putting a function together with its inverse. So what happens? You know, I'm starting out here with x. X goes into what? This one right here, log base A, and comes out over here as log base A of x. Then I'm sending that back through the A to the x function. So where should it go back to? Where did it start? X went through here, came out to be something, and then it goes back through and comes back to x, right? So the answer to this should be x. That makes sense to you? If you put an exponential function together with its inverse log, then they're going to wipe each other out, and the x just falls out. Now let's do that property with this particular special. So these are the special ones. If you're coming in, just walking in, this is the special. I can't even spell special. Okay, this is the general property of logarithms for any logarithm, and then these are the two special ones. All right, maybe I shouldn't have arrows. I should just put these as columns instead. Okay, so this property, all right, let's write it. What would be the base if I'm in this special case here? What's the base of this log? 10. So this property is saying if I take 10 and raise it to the log x. Notice I wrote log x, not log base 10, because it's the special one, isn't it? So if you take 10 and raise it to the log x, which is really log base 10x, you should just get, bless you, you should just get x, shouldn't you? And what about this one? What's the base here? What's the base of this special log? What? E, right? So if you take E and you raise it to the natural log x, you should just get what? X. So in general, any base raised to log base of that same A of x, the x just falls out. This specific special case, the base is 10, so 10 raised to the log base 10 of x should just give you x. Here the base is E, so E raised to the log base E of x should be x as well. Any questions? All right, the third property says that we can do it the other way around. Here, if I take log base A, and inside of it, I put the inverse of that, which is a to the x. See, I'm taking log base A, and what am I plugging in? I guess I could put parentheses here if I wanted to. I'm putting into this function its inverse. And so they should wipe each other out, and I should just get x. for the same exact reason that the other one wiped out. Do y'all want to see the picture of this, or y'all okay? Okay, picture. The picture of this one is that x starts here and goes through what function first? Which one? This, right? So it goes through a to the x first. It comes out over here as a to the x. Then it goes through what function? The log base a, which is its inverse, right? That takes it back to x. Okay? That's different than the picture I drew a second ago. The one I did for this one, it went through log first and then went through the a to the, I'm sorry. Yeah, it went through log first, then a to the x. Here we're just doing it in the reverse order. So what would that look like here? Here, what's our log, what's our base here? 10, so I don't write it. And then inside here I put what? A to the x, but what's a here? 10. So 10 to the x, this should just be x. So if you take log of 10 to the x, you should just get x. How about this one? What's the log here? The ln, right? The natural log. Natural log, okay. So I don't write the base. And then what goes in it? E to the x, right? E to the x. And you get x. So this is just, these two have to do with the fact that they're inverses. If you put e together with its inverse, they kill each other off, you just get the x. If you put natural log together with its inverse, e to the x, then they kill each other off and you just get x. Okay, all three of those properties are going to be used a lot going down the road for you. Yes?
When do they not cancel?
They always cancel. Now this, okay, so this wouldn't, okay, let me show you an example of something that wouldn't. If I wrote log base 3 of 4 to the x, this would not be equal to x because this base and this base aren't the same, right? Now, if I change this to a 4, then it would be x. Or if I change that to a 3, this would be x. They have to be the same, though. I don't know if that's what you're asking, but okay. So these are properties. Properties means these always hold. Okay, these are always going to be true. All right, next property. All right, these properties are strange, all right? The logarithms behave in a very weird way. This fourth property says, and I'm going to use, again, different notation than they're using. If you take log base a, so any logarithm, right, any logarithm you want, and inside that log, you put the product of two things. Do y'all see we have a single logarithm, right? Do y'all see the single logarithm? Log, base a, and inside that log I have two things being multiplied, all right? What this property says is that this becomes log base a of x plus log base a of y. Okay, what happened? I had one log, and inside of it I had what? I had multiplication, right? Single log, multiplication inside. This property says that when you have a single log with multiplication inside, you can split that into two logarithms with addition between them. The first log will have the x, the second log will have the y. Okay?
Like the exponent?
It's kind of like the exponent rule.
Like x?
Yeah, it's kind of like this. If you have a to the, what, x plus y, that means a to the x times a to the y. I don't know if that's what you mean, but that's actually exactly where it comes from, is from this property right here, but for logarithms. Okay, now let's do it for the special case. This is let's do the log base 10. I'm just going to put 10 up here and e over here. These are our two special bases. So to write this, it would be log, I don't write the base, xy. I'm just going to put xy instead of x with a dot in the middle. It's implied that there's a dot there, right? This becomes, what? You tell me. Log. Don't write the base. Log x plus log y. Done. Okay? Now let's look at this one. This one would say natural log of xy, x times y, would become what? ln x, natural log x, plus ln y. There you go. That's it. That's your property. It's your fourth property. All right, ready for the fifth one? I think you're going to be able to figure this one out without looking at the screen over there. What do you think happens if instead of having multiplication, I have division? Subtraction. Exactly. Instead of having addition, we're going to have subtraction between the logs. So this will become log base a of x minus log base a of y. So multiplication inside of a single log becomes addition of two logs. Division inside of a single log becomes subtraction of two logs. And then our special cases. I would write log of x over y, and this would be log x minus log y. Over here, we'd have natural log of x over y. This would be natural log x minus natural log y. Okay, y'all doing all right? There's only 32 properties, so we're getting there. I'm kidding, there's not. We're almost done. Okay, next property. Now this one, extremely important. They're all important, but this one comes into play. It's a weird one, okay? So look, it says, if I have log base a of x, I'm using different notation. I'm using notation you'll see in a calculus textbook, all right? So that way when you get to calculus, you'll have this notation, x to the n. Okay, so please understand that with that notation, that power n is acting on the x, all right? It's x raised to the n. Do not confuse that with this. This is not the same thing. This would mean figure out what this is and then raise the whole thing to the nth power. That's not what I'm talking about here. Here, the n is only acting on the x, all right? Now, look at the property. Look at the property. I'm going to show it to you. Ready? This property says what I can do is I can take that n and I can pop it out to the front like a number and just put n times log base a of x. The n pops out front. Now, I can show you why that's true quickly. All right, I can show you why that's true. What's happening here is that what you have is log base a. Okay, you have x multiplied n times, right? So you have x times x times x. How many of these do we have? We have n of these, right? And there's multiplication between each one, right? Well, we can use this property that says every time you have multiplication, you can turn it into addition, right? So what this becomes is log base a of x plus 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 how many of these logs will I have? I'll have n of these, right? I'll have n of these. And that's why we're just saying, yeah, it's just n of those. But the property is just strange because you're just allowed to pop the power out. I cannot tell you how much that's used in calculus. It's too much, all right? All right, we continue. Let's do our special cases. What does that property look like here? Log, no base, right? X to the n equals n log x. That just says if you have that power, you pop it out front. Here, in this special case, natural log x to the n is n natural log x. And that's a multiplication, right? I'm not writing these normally, but it's implied that those are multiplications. And you have to learn these. You have to know these, all right? Your success down the road will be somewhat dependent on your memorization of these formulas. All right, so now we get to do some examples. It's like now we have all the properties. Let's do something with them. And right now, what we're doing is not going to make, well, let me say this. A lot of times we use these properties of logs in other classes to make other problems easier to do, all right? So when we do this, you're going to be like, well, what's the point? Well, the point is later on, you're going to use this, all right? You get a hard problem, you use the properties, it becomes easier. All right, how many properties did I give you? Is that 6? Okay, 6 properties, and I numbered them 1 through 6, right? You've got them all there? Okay, I'm going to write this down. I have log base A of parentheses x times the square root of x squared plus 1. And they're telling us that x is greater than or equal to 0. Now, they're telling us this because, remember, you cannot plug, greater, sorry. You cannot plug when it comes to any logarithm, what's in here has to be positive. We talked about domains last time. This has to be positive. So this is just letting us know, hey, this x in here is positive. Don't worry about it. We don't have any domain problems, all right? So here are the instructions. The instructions are expand this. Expand. Those are the instructions. So what this means is that we want to make this one log turn into a bunch of logs, all right? So the first thing that I see here is that I have multiplication right there, right? Between two things. Multiplication, I have a single log and I have multiplication inside, right? Between the x and the square root, right? So I'm going to use property 4, property 4. And I'm going to turn this into 2 logarithms. The first one is log base a of x. And then I'm going to put plus. And now I have another one, log base a of what? This right here with the square root, right? Yes? Now, are y'all okay if I write that this way instead? Is that okay if I, instead of writing the square root, can I just raise it to the half power? Are you comfortable with that?
Yep.
No? Isn't that what square root means? Doesn't square root of x mean x to the half? Doesn't cube root mean x to the 1/3? Doesn't fourth root mean x to the 1/4? Right? That's what all this means, right? So instead of, I'm splitting this into 2 logs because I have multiplication, but instead of writing square root of that, I'm writing all of that to the half. That better? That good? Now, why do you think I wrote it to the half instead of leaving it as a square root? Why do you think I did that? Just for fun? Because property 6 allows me to take powers out front, doesn't it? So this right here, okay, this is going to come out front. But let's just look at everything we have. Log base a of x. There's nothing more I can do with this, right? I don't have multiplication inside, right? I don't have division inside here. I don't have a power. There's nothing more for me to do. But on this one, I can bring the 1/2 power out using property 6. So I'm going to do that now. So I bring the 1/2 out in front. I write log base a of x squared plus 1. Notice I left the x squared plus 1 in parentheses. You have to write it that way. So this half came out front using property 6, right? I split this into 2 logs, right? I split this into 2 logs using property 4. Questions? So the question now becomes, are we done? And what you need to look is see if you can use any properties that you have there to clean this up. So look at this logarithm. We already said this log, you can't really do anything with it, right? But this one right here, we have log base a, and inside we have what? 2 things being added together, right? Added together. Did I give you any properties that told you how to handle something if you have addition inside of a log? No, I never did I? Right? Did I give you a property that looked like this? I didn't give you anything that said what happens if you have 2 things added inside, right? I didn't give you anything like this. And I'll tell you what, this does not equal what most students will do is they'll say, oh, I'm going to distribute the log through. The log is not a number, okay? You can't distribute it through like that. So students will say, oh, this is log base ax plus log base ay. Well, what's wrong with that? This is what you get when you have multiplication in here, right? So how can it be this when you have addition as well? So this is no good, all right? So basically we're done. There's nothing more we can do here. There's nothing more we can do here, and we are done. We have expanded this logarithmic expression. Started out as a single log, and we ripped it apart, and now it becomes 2 logs. All right?
So it's kind of like factors, but for logs.
Technically, factoring is turning additions and subtractions into multiplication. So what we did is we turned something that had multiplication into addition and subtraction. So it would almost be like a reverse of that. Like foiling it out almost. But I don't want to say that because we didn't like multiply anything through. We just used properties. All right, I think we should do another one, yeah? Same instructions, expand. So we have natural log. This is the way they write it, natural log, and then they just put x squared over x minus 1 cubed. And they also tell you that x is greater than 1. They're only telling you this so that you know they're giving you the domain. In other words, you're not having to work to figure out what the domain is. So there it is, and we want to expand it. We want to rip this apart into multiple logs if we can. So what do y'all see first? Everyone see division? Everyone see division in there? Okay, how about the 2? Can we pull the 2 out? Not yet, okay, because what we'd have to have here is log of something to that power. Here the power, we have 2 different powers and 2 different things. So we can't pull a 2 out, can't pull a 3 out. We have to first use the division property to turn this into 2 logs with subtraction. So this becomes, through property 5, or I'm just going to put 5 here, becomes natural log of what? X squared minus, then another natural log, and then I'm going to write x minus 1 cubed. That's property 5. And now I'm going to use property 6. Property 6 is going to allow me to pop that 2 out front here, pop the 3 out front here. So we have 2 natural log x minus 3 natural log of x minus 1. Any questions on that?
That's it, right?
That should be it. There's nothing more we can do because we can't do anything to this, right? That's subtraction inside. We don't have any properties about how to deal with subtraction inside of a log. So we're done. Box it up, we're done. All right, now our last one, our last example. We might do more if we have some time at the end. What we're doing right now is we're working through every example in this section. Every example that they have when they're showing you the properties, here's the examples, we're doing every one. But even when you do all the examples, I don't think it's enough to really feel comfortable. You have to do more, which is what the homework is for. All right, actually, I'm gonna do that one over here. So log base A, I'm gonna change the problem a little bit. I'm just gonna put log, and then we're gonna have square root x squared plus 1 over x cubed, ooh, this is a good one, and then x plus 1 to the 4th. There we go. All right, what I'd like to do is see if I can pull that apart into a bunch of logs. The first thing you have to see is that you have division, right? You have log of something over something, right? Division. So I'm going to use property 5 and create 2 logs with subtraction. That's my first thing. So property 5 now, log of the square root of x squared plus 1. I guess I could have done to the 1/2, couldn't I? Yeah, do you want me to do that now? We do it now? Let's do it now. Okay, let's do that to the 1/2. And then minus now another log, right? And what's inside this log? The entire denominator, right? So watch the way I write that. I'm going to do x cubed and then x plus 1 to the 4th. See how I wrote that? I took the entire denominator and I put it in this new log. That's property 5. Questions there? Can we do anything to this? What property? 6, right? We pull the half out. Okay, let's do that. Pull the half out. Log x squared plus 1. Right, that I use property 6. I'm just going to put a little 6 above it so you can know what I did from here to here. Property 6. Pulled the half out. Now, here, this is where people have a little bit of trouble. What do you see here? Multiplication inside that log, right? We have multiplication inside that log, right here. We have multiplication. And so property 4, right? Property 4 allows us to turn multiplication into 2 logs, right? 2 logs. However, there's a negative out here. And so that negative would be applied to both of those new logs. So when I write this, watch the way I do it. I'm going to do minus. I'm going to put a bracket so I don't screw it up. And then I'm going to put log of x cubed plus log of x plus 1, x plus 1 to the 4th. For that, I used property 4, right, on this thing right here. What students will do is they'll forget this negative and they'll write this without the bracket. And the problem with that is this negative will eventually have to distribute to both. So you'll have a negative in front of this one and this one.
If you leave it like that, it's still correct. Like with the brackets.
That is correct, but we're not completely expanded out yet because we need to do something else. What can we do?